Hello everyone, it's time to review for the final. So to review for the final, we are going to do our little crash course here. I'm going to go through as much of this stuff as I can, give you guys some of the big ideas that you know you're going to see on your exam. So first thing we've got is a 3-variable system. And when you have a 3-variable system, you got to remember the goal is to eliminate one variable 2 different ways. So if you sometimes work smarter, you can make this a lot easier. Like I see like 2 could go into 4, but 3 wouldn't go into 4, so I'd have to mess with 2 equations. 2 could go into 4 and 2 could go into 6. I could do that one, or I could get rid of y. I think I'm going to get rid of x, okay? So I'll call this line 1, line 2, line 3. I think I'm going to get rid of x. And the first way I'm going to get rid of x is I want this to be -6 and +6, so I'm going to use lines 1 and 3. But I need this to be -6, so I have to multiply the whole thing by 3. So I'm going to triple line 1, and now I get -6x plus 9y plus 12z equals 29 times 3 is 87, so -87. I'm multiplying all of these values times 3, and then I won't change this one at all. So I might need a calculator for this one. But this is, again, 3 times line 1 and line 3. Okay, we'll do that in a second. The other way I'm going to get rid of x is I think I'm going to multiply. I want this to be +4 so that it cancels out with -4. So I will multiply line 1 times -2. So now it's +4x, -6y, -8z, and -2 times -29 is +58. And then we'll do line 2. So -4x plus y minus 2z equals -13. All right, so those are my setups. And the reason that I know that I feel good about those is because x is going to cancel in both of them. 9 minus 4 is 5y. 12 minus 3 is 9, and that's z. And then let's just make sure -87 plus 44 is -43. Good, -43. We'll call that line A. -6 and 1 make -5. -8 and -2 make -10. And 58 minus 13 is 43. We'll call it 45. We will call that line B. 58 minus 13 is 45. So let's see. I've got 2 equations and I only have y's and z's. That's good. So I've eliminated x. Now I got to get rid of one of those. Which one do we want to get? Actually, look, positive and negative. It's set up. We got really lucky. So just because I kind of happened to pick the right 2 to get rid of, I got lucky here. And A and B are already set up to cancel out y. So this is going to cancel. -10 and +9 make -1z, and 45 minus 43 is 2, so that means z is -2. Once you get one of them, now you work your way back up. I'm just going to plug this in right here. 5y plus 9 times -2 is -43. 5y minus 18 is -43. If you add 18 to both sides, -43 plus 18 is -25. And that means that y is -5. All right, we got 2 of the 3. On a multiple choice test, that's probably going to be sufficient. But let's get x just for good measure. Which one do I want to use? I'll pick this one's got positive. I like that better. Okay, so we'll use this guy. So 6x minus 4, y is -5, minus 3, z is -2. 6x plus 20 plus 6, which is 26. If you subtract 26 on both sides, you get 18, which means x is 3. So as an ordered triple, we have 3, -5, -2. All right, and you can check it, and it's a good idea to check it. And honestly, if it's a multiple choice test, this might be the fastest way to do the problem. Instead of even working it out, you might just work backwards. So let's see what happens when I check this. I'm going to use my calculator here, and I'm just going to plug it into all 3. -2 times 3 plus 3 times -5 plus 4 times -2. So if I plug it in the first one, I better get -29. Yes. -4 times 3 plus -5 minus 2 times negative 2. If I plug it in the second one, I better get negative 13. Yes, one more. 6 times 3 minus 4 times negative 5. Come on, let's get 44. Yes, we got it. Okay, I know I did it right. Again, on a multiple choice test, you might just work backwards, plug them in, see which one you get. Okay, it's probably faster than working out a 3-variable system, especially if it goes wrong. If you mess something up, work backwards. All right, let's practice solving. So if you see that you have an x squared and an x to the first, your brain should be thinking, I must factor. So let's get everything on one side. 2x squared plus x. Negative 15 and 5 make negative 10. And now we are going to split the middle. So what numbers multiply to AC, that is negative 20, and add to 1? If you want to make a table, 1 and 20, 2 and 10, 4 and 5, there it is. Negative 4, positive 5. 2x squared minus 4x plus 5x minus 10. And now we're factoring by grouping. So you find the GCF of each half. The GCF of the first two is 2x. Bring down the plus sign. The GCF of the second two is 5. Hey, x minus 2 is shared. 2x plus 5 is the other 0. That's a good sign. So when does x minus 2 equal 0? When x equals 2. And when does that equal 0? You would subtract 5 and divide by 2. If you had to solve that equation, minus 5 divided by 2, those are your zeros. Same game for this one. Get everything on one side, so you have to subtract the 5x first. And now you have to find numbers that multiply to 3 and add to negative 5. Wait, that's not going to work. Nothing's going to multiply to 3 and add to negative 5. Guess we're doing the quadratic formula. So first, b squared minus 4ac, 25 minus 12 is 13. So it's 5 plus or minus the square root of 13 over 2a, 2 times 3 is 6. If you don't remember the quadratic formula, put this on your cheat sheet, over 2a. Okay. I do the discriminant first, and that was 13. And then it's the opposite of b. The opposite of negative 5 is 5, plus or minus square root of radical 13 over 2a, 2 times 3 is 6. So these are your x-intercepts. They're gross, but you should be pretty comfortable with quadratic formula by now. We've done it a bunch. All right, then we started doing some quadratics. So if you're trying to solve this, you want to isolate the squared term, which means you need to first subtract 18. 9 minus 18 is negative 9. Then divide by 3. X minus 4 squared equals negative 3. Now I can undo the squaring by square rooting, and you should hopefully realize that the square root of negative anything is imaginary, and we're just going to say this is plus or minus I radical 3. You can't simplify radical 3, but you can say it's imaginary. And then when you add 4, 4 plus or minus I radical 3. Those are your two imaginary zeros. What would you complete the square with? Remember, you start with something like this, and you would move the 15 over. We don't actually need to do the whole thing. We just need to figure out what would be in the corner. And the way I drew this is I draw a picture. It's always x minus, or x plus half of b, half of negative 6 is negative 3. So what would this corner be? 3 times 3 is 9. So you would add 9 to both sides. And the factored form would look like this. Negative 15, like that. And you could keep going, but we don't need to. Okay, it just says what would you complete the square with? 9. Find x-intercepts. X-intercepts should be easy. It's 1 and negative 2. Plug in 1, you get 0. Plug in negative 2, you get 0. That's easy. To find the vertex, you could think about intercept form, find the middle of 1 and negative 2, or you could just graph it in Desmos, because you got Desmos. It's right here. The vertex is negative 0.5, negative 4.5. Negative 0.5, negative 4.5. We did it. Okay. Standard form. All right, you got to expand this. So write it out twice. Now we FOIL. X squared minus 5x minus 5x. Negative times a negative is positive 25. I got plus 6 on the end. X squared minus 10x plus 31. So that is the standard form. The axis of symmetry, well, hopefully you remember this is vertex form, and the vertex is at 5, 6. It goes right 5, up 6. So the vertex will be at 5, 6, which means the axis of symmetry is 5. It goes through. If you know the vertex is right here on a parabola that opens up, the axis of symmetry is what goes through it. It goes through the middle. The middle is 5. So here's standard form. Here's the vertex. Here's the axis of symmetry, whatever else you need. Graph it. Done. There's the graph. The intercepts you should be able to easily identify are at -4 and +3. Here's the vertex. There's the y-intercept. Okay? Just use Desmos. If you have Desmos, use Desmos. All right, factoring. So this is the quadratic form. See how it's 4 and 2? We're going to pretend like it's 2 and 1. We're just working in a higher degree. So we're split in the middle. What multiplies to 3 times 21 is 63 and adds to -2. Let's see, 1 and 63, 3 and 21, 2, 3, 4, 5, 6, 7 and 9. There it is. And we want them to add to -2, so make the 9 negative. So when you split the middle, though, this is 3x to the 4th. Ooh, wrong button. 3x to the 4th. And then I'm going to do plus 7x squared minus 9x squared plus 21. Because this is squared, those have to be squared. And this is to the 4th, so that's still to the 4th. This just means that when you do the grouping, it's a little trickier. The GCF is x squared. And the GCF here, 9 and 21 are both multiples of 3. And again, I'm factoring out a -3, so this is going to be, wait a minute. Something doesn't seem right. -3. This would be -7? X squared. What did I do wrong? I want +7 and -9. No, my mistake I made at the beginning was I thought it was -63. This is not factorable the way it's written. We need to make this a -21. There's a typo here. So that's why this isn't working. It's because this question is not factorable. I need to fix this. So I'll fix it on the actual copy, so you shouldn't see it. You should see -21. But you got -21, so it is -7 or 7 and -9. But what happens here is this is -21, so now it'll be +7. Now they match up. So I got to fix that. X squared minus 3, and then 3x squared plus 7 is the factored form. Okay, there are no numbers that add to -2 if they have to have opposite signs. All right, so now sometimes you can keep going in this one. Like if this was a 9, that would be dots. It'd be x plus 3, x minus 3. But in this problem, we can't keep going because it's not a perfect square, so you are finished. But I will fix that on the packet. Second one, factor. These are both perfect squares, so it's dots. 2x plus 9, 2x minus 9. That's it. You should recognize those. Simplify means to expand out, so I'm going to just distribute. 3x cubed negative times positive is -4x squared. And that'll do the same thing with the -2x. -2 times +3 is -6. X times x is x squared. -2 times -4 is +8. X comes along. Now we do the same thing with 3. So now that would be 9x minus 12. Combine like terms. 3x cubed minus 10x squared plus 17x minus 12. That's all you can do. You're done. One more factor problem. So if you look at this, you're like, oh, perfect cubed. Yes, but you need to factor out the GCF first for it to actually be something we can factor. Okay, you see that there's an x cubed, but 2 is not a perfect cube, and 250 is not a perfect cube. So you have to first do GCF, and now we can say, okay, this is a formula. A, B, A squared, AB, B squared. So the 2 is not going to change. But now the cube root of x cubed, that's your A term, that's x. And the cube root of 125 is 5. So A is x and B is 5. And now I'm going to do A squared, x squared. A times B, 5x, B squared, 25. And the trick we use for the signs is SOAP. So if this is minus, that's the same, opposite, always positive. Same, opposite, always positive. These are the same. This one's always the opposite, and this one's always positive. So we say SOAP for the signs. That is the completely factored form. All right, use Desmos to graph the polynomial and analyze. Okay, let's use Desmos. We got it right here. What do we need to know? We need to know, first of all, end behavior. It looks kind of like a W. So that means it's going up on both ends. So we'll say y goes to infinity as x goes to infinity. This means up and right and up and left. So it's going up on both ends. So both of the y's are to infinity. Local mins are turnarounds at the bottom. So let's see, local minimums are right here. Okay, those are the local mins. I'm just going to screenshot them so I don't have to remember all those digits. That's a local minimum, and this is a local minimum. You're looking for turnaround points. Local maximum is also a turnaround point right there at the top. So that's this guy. Be careful, don't get the y-intercept. And then the last thing, identify real zeros. Real zeros are where it hits the x-axis. So those are the two x-intercepts. And hopefully you realize that if you have two x-intercepts in a quartic, that means the other two that you would find, this is degree 4, so there's 4 zeros. 2 of them are real, the other 2 are imaginary, or complex zeros. Complex number operations, let's FOIL. 4 times 7 is 28, 4 times 5i is 20i. Negative 2 times 7 is negative 14, that's got an I. And negative 2 times 10, or negative 2 times 5 is negative 10 I squared. And what you need to remember is that the square root of negative 1 is I. So I squared is actually negative 1. This is negative 1. So 28 plus 20 minus 14 is 6i. And then negative 10 times negative 1 is 10. So this is 38 plus 6i. That's the simplified form. There should be no I squareds. A plus bi is standard form for a complex number. This says addition, so just combine my terms. The parentheses don't matter. Minus 3 plus I. Just combine my terms. 12 minus 3 is 9. Negative 9 plus 1 is negative 8i. Do not FOIL it out if you don't need to. This is just addition. Exponents and radicals. So this is the most recent unit. It should be pretty fresh in your head. When you multiply with the same base, you add the exponents. So I'm going to add, I'll put that in the background so I can see it. 3 plus 1/2. 3 plus 1/2. So 3, I need this to be 2 in the bottom. So if I do it in the bottom, I have to do it in the top. That way I can add them. 3 times 2 is 6. 6 plus 1 is 7/2. Another way of thinking about this. How many halves are in 3 whole? 6. 6 halves. 6 halves plus 1 more half is 7 halves. This is 5n to the 7 halves. Second one, we're going to multiply all the exponents. Be careful. That's 3 to the second. Negative 2/3 times 2 over 1 is negative 4/3. You just multiply fractions across. 2 times 2 is 4. 3 times 1 is 3. So this is n to the negative 4/3. Now, I can do two things. 3 squared is 9, and this will move to the bottom. So 9 over n to the 4/3. Evaluate. The cube root of 64 is 4, and 4 squared is 16. So that is 16. Similarly, the fifth root of 32 is 2. 2 to the negative first is 1 over 2 to the first. So that one's 1/2. If you rewrite this as an exponent, it's a to the, just remember the root is the denominator, the power is the numerator. So a to the 3/4. And going the other way, the root is the denominator. So this is the third root of x squared, or you could write it like this. Those are the same thing. They're both correct. Last thing, we got to do a little solving. So first, isolate the exponent, or the rational exponent anyway. And now we got x to the 3/2 equals 32 divided by 4 is 8. Now, to undo 3/2, we're going to multiply, or take the 2/3 power of both sides, the 2/3 power. And the reason we're doing that is if you take the reciprocal, when you multiply, 3 times 2, you get 6 over 6. This is all going to cancel out. It's going to be 1, x to the first. And on the right side, this is what we just talked about. The cube root of 8 is 2, and 2 squared is 4. So x equals 4. You take the cube root of 8, and then you square it. The cube root of 8 is 2, 2 squared is 4. Last thing, find the inverse. So flip x and y. X is now y is now x, and now the goal is to solve for y. So to solve for y, x plus 1 equals 4y. Divide everything by 4. and you just leave it like that. Boom. And if you want to be fancy, you can write it as F inverse. But they didn't use function notation to start. So I don't really have to do that at the end. All right. If you can do this crash course, you should be in pretty good shape. You have a good basic skill set. So get the practice final done. Make sure you get everything else done. And you're going to crush this final. And while you're at it, maybe hit that like and subscribe. Good luck on your final.